My name is Chu Jiaxing. Matrix number is A170499. Regarding to project 1, I will plan to design a laser tachometer. So for our project 1, our hardware design is a laser tachometer. A laser tachometer uses a laser or similar light source to shoot light towards the object that we want to measure. The light is aimed at a reflective marks on the object that we want to measure. The reflected light gets picked up by victim sensor and will then count how many times the sensor is triggered during some duration of time. So for application of laser tachometer, a laser tachometer is normally used to measure the revolution of spinning object to determine the rate at which it is spinning. The instrument is also vital in troubleshooting machinery performance and conducting preventive maintenance inspection. Nowadays, nearly all types of transportation vehicle has tachometers. Tachometers are mostly used for production line check, monitoring turbine, measuring sewing machine speed, and maintaining quality control. A tachometer is actually a system of monitoring equipment that captures data, relays it to the ECU. ECU means engine control units and impacts to the operation of several independent systems. Officially, a tachometer is an instrument measuring the rotation speed of the shaft of this as in a motor or other machine. For example, in a vehicle, a tachometer measures the rotation of the engine crankshaft, which is responsible for rotating each connecting rods on piston through the combustion cycle. As the crankshaft spins 360 degrees, it completes a revolution. Rotation speed is measured in revolution per minute. So how to build a laser tachometer? To build a laser tachometer, the critical component required includes a microprocessor, an input-output, as well as power source. A microprocessor is central processing unit of device. We will use ATmega328P, which is an 8-bit microcontroller. For input, we will use a laser sensor module and laser diode to test the rotation speed of the spinning object. The laser sensor module is responsible for detecting the reflection of light from the laser diode. For output, we will be using an OLED display, which will show us the reading of our measurements. To power all the components, we plan to use a replaceable battery, which is convenient for public. For the PCB board design, our group used the software Easy EDA to do all the wiring between all the components. So my contribution in this project is, first, give idea to the hardware design, like how to design a tachometer, or we need what component to do so, and how to make sure the tachometer can function well. So second is my contribution is to estimate production cost. To do this, so because before heading to the drawing boards, the laser tachometer we have in mind should not only be accurate and consistent, but also affordable. We certainly want to ensure that the instrument is lightweight and portable as well. The main raw material for the casing is polycarbonate to keep the weight of the instrument as light as possible. The other component includes a microcontroller, output display, input sensor, disposable battery, and more. This is our estimation price for our design. So the total estimated price is 51 ringgit and 22 cents.